Hi, so I'm making this video in response to a post from user DeepDive007 on the A-Level Physics subreddit. And so this is for you, DeepDive007, but anyone else who would find this useful can watch this as well. And it's about the role of air resistance, and this is fairly standard in an A-Level Physics question. I'll show you the question. But you've done some sort of calculation. It looks like a SUVAC question. The user didn't provide the rest of the question. But as you can see here, they've done some calculation. It looks like they've calculated the time for the ball to reach its maximum height. And the question asks, in practice, air resistance is not negligible. State and explain the effect of air resistance on the time taken for the ball to reach its maximum height. Okay, so our gut instinct, probably most of you would think that, okay, if a ball reaches a particular height and falls back down, without air resistance, the inclusion of air resistance will make it reach less of a height. Okay, so it won't reach the same height, and so that probably tells us it would take less time. So the state part of the question is to say it would take less time. I think this is a 2-mark question. And then the explain part, we have to say why it is going to take less time. Well, air resistance acts in the opposite direction to where the ball is moving. Okay, so the mark scheme that the Reddit user provided said deceleration is greater, is the explanation. Deceleration. But why is deceleration greater? Well, let's imagine the ball with no air resistance. There's one force acting on it, which is its weight acting downwards. According to Newton's second law, the acceleration will also be downwards because there is a resultant force in the downward direction, and Newton's second law tells us F equals ma. The acceleration of the object, or deceleration in this case, is directly proportional to the resultant force acting on it, because in this situation, the ball has an upward velocity, but a downward acceleration. And when velocity and acceleration are in opposite directions, that means the ball is slowing down. If we now include air resistance in this, we also have air resistance, or drag, acting in the same direction as the weight. So the resultant force has increased. So the deceleration has increased, which means it decreases its velocity to 0 more quickly, which is the explanation for this question. So DeepDive007, I hope you find that useful. If you have any follow-up questions, do feel free to drop them in the Reddit comments. Thanks.